Hello friends, welcome to Suresh Aggarwal's Mathematics Shortcuts. This is a channel where you find all the smart tricks which help you calculate 10 times faster and helps you crack the multiple choice questions smartly, because you have like 100 questions to be done in a quantitative aptitude exam and around 90 minutes to solve those questions. So traditional methods, yes, they are useful in understanding the logic behind why we are doing particular steps, but they are not going to help you in saving time in the quant exams. These are the tricks which you should know, which you must know and practice, so that you come out successfully in all those Olympiads if you are appearing at the school level, placement exams at professional level, and if you are getting into some university, good university, they will also conduct entrance examinations and test you for your smartness. So in this video, I am going to extrapolate the concept which I took up in my previous video. The previous video was based on finding the LCM of decimals, and this video is based on finding the HCF, the highest common factor of decimals. We all know what is HCF, the highest common factor, but can we do it for decimals? I think 99% of the students will say with little practice, and I'll show you how smartness works. And this trick is from our chapter number 6, Conquer Decimals, of our ebook of short tricks, which contains 350 such smart methods. If you want a copy of that compilation, you have to send me a message on WhatsApp. This is the WhatsApp number 9896369963. So send me a message so that you can get a copy and preserve it for life, and this will help you in whatever subject you are studying. These tricks are used everywhere. So let's understand the trick by applying it to some very basic questions first. Here we have a question where we have to find the HCF of 6.6 and 1.2. Now one important observation here is how many decimal places the numbers have. Are they equal or unequal? So after decimal you have one digit here and one digit here, and when we have equal number of decimal places, things are a little bit easier. But we are going to do questions where the number of digits after decimal are going to differ. Okay, so that will complete the trick. So let's understand this first. Once you know that there are equal number of digits after decimal, just forget the decimal and write the numbers 66 and 12. Now 66 and 12, they are divisible by 2, which gives me a 33 here and a 6 here. Now both of them are divisible by 3, so 3 2s are, so I'll write a 3 also here. That gives me 11 and a 2. Now 11 and 2 are co-prime. No more common factors. So the HCF of the numbers 66 and 12 is 2 into 3, 6. So I'll write 66 and 12 is 6. Right? The highest common factor is this 2 into 3, 6. Now since our decimals had one decimal place each, so your answer will also have one decimal place finally. Okay, now 6 becomes 0.6 because I have to put a decimal one digit from the right hand side. So you can check for 6.6 and 1.2, 0.6 is going to be the highest common factor. Likewise, if you see this question, we have two decimal places here, two decimal places here. So forget the decimal, this becomes 84 and this becomes 154. Now you have to be smart. You should know the highest common factor first. Now if I see both are even numbers, they are divisible by 2. So this is 42 and this is 77. Now 77 is an odd number, so 2 is ruled out now, and 77 is obviously divisible by 7 only, and 7 divides 42 also. Now if I extract the 7, the 2 becomes 2 7s are 14, and if you divide 42 by 7 you get 6, 77 by 7 you get 11. These are co-prime, and therefore the highest common factor of these numbers 84 and 154 is 14. Therefore what will be the highest common factor of your answer? 2 decimal places, 2 decimal places. So 2 decimal places in the answer also becomes 0.14. Now you can pick up the calculators and try these things using the calculator, and obviously you have smart apps, you have so many websites which can tell you the HCF of these numbers directly. Just check and let me know the accuracy of this method. 0.14 is the answer. Likewise, here you can see 1 digit after decimal, 1 digit after decimal. So this becomes 88 and this becomes 102. Divisible by 2, right? So this is 44 and this is 51. Now this actually is 3 times 17, right? And 3 doesn't divide 44, 17 doesn't divide 44. So the highest common factor of 88 and 102 is going to be 2 only. And so the highest common factor of the required numbers, 1 decimal place. So 1 decimal place means 0.2 is the highest common factor. Likewise here, one more question of having equal digits after decimal. 1 digit, 1 digit, 1 digit. So this is 15, this is 25 and this is 35. So obvious highest common factor is 5, right? For all these numbers, they are not going to be divisible by any bigger number than 5. So the highest common factor of these numbers will be 1 digit after decimal means 0.5 will be the answer. Very easy, right? Okay. Can be extrapolated to this question now. Now this is going to be little bit more testing. Now why? Because 1 digit here, 1 digit here and 1 digit here, but the numbers are 3 digit numbers. 189, 273 and 4, 5, 9. 9 plus 1, 10 plus 8, 18 divisible by 3. 7 plus 3, 10 plus 2, 12 divisible by 3. 5 plus 4, 9 plus 9, 18 divisible by 3. So if you divide by 3, you get 63 here, 91 here, 153 here. Now, how do I check by which numbers are they divisible? 91 is 13 into 7, right? Now, 7 divides 63 correctly, but 13 doesn't divide 63. So 13 is ruled out. 7 can be a possibility. Let's see here 153. Now, if you see 153, it is 17 times 9. So 17 doesn't divide 63, ruled out. 9 is 3 into 3 only, and 3 is not a factor of 91, and so there are no more common factors, and so the highest common factor of the numbers is just 3, and 3 means now you have to put a decimal 1 digit from the right hand side, so 3 becomes 0.3, which is the highest common factor of all these numbers. Likewise here, 1 digit here, there is no digit here and 1 digit here. So what do we do with this? 120 becomes 120.0 because we need to have 1 digit after decimal. So this becomes 864, this becomes 1200 and then this becomes 164. Now you will see that if you extract the common factor 4, you will have 4 2s are and then 16s are, 4 3s are and 2 zeros, 4 4s are and 1s are, right? Now 41 no way can divide these numbers, and 41 is a prime number, and therefore the highest common factor is 4 itself, but 1 digit after decimal will give you 0.4 as the HCF of the decimal numbers. See, little bit of understanding, little bit of smartness, and you can actually find that highest common factor so very easily. So friends, if you like this video, do share it with all your friends on your various social media platforms so that they can also enjoy these smart methods, and do subscribe to our YouTube channel Suresh Aggarwal's Mathematics Shortcuts. Hit the bell icon for getting all the notifications on your mobile itself. Practice is very important. Pick up the previous year papers and practice 30-40 such questions of finding the HCF of decimals, and let me know in the comments below, is it working for you? All the best.